Hi, welcome to today's lesson on point-slope form. This is going to be the first of two-part lesson on the subject. Okay, point-slope form is of a linear equation, so it's the equation of a line, and it's one of the many forms. The last couple of lessons we saw slope-intercept form, probably the most important form, but point-slope is a very versatile form and it's very useful. It's probably the easiest to write based on the types of information that you're going to be given in various problems and in various situations, even just lifelike situations. You know, if you're really just trying to find a couple of points, I'm trying to find a trajectory between them, this would be the form I would use. So let's look at, well, what is point-slope form? So we'll start with that question. What is point, abbreviated PT, slope form? And here's how it looks. It's y minus y1. Y1, we'll talk about what that means in just a split second here, equals m times, parentheses, x minus x1. Okay, so let's break this all down so we know what all these pieces represent. So m, we know m means slope. It was slope when we used the slope formula. It was slope when we used the slope-intercept form. In all those situations, m represents slope. So we're going to keep using m to represent slope, and that's the slope part of this. Now, the other part is the point. Every point in mathematics is always x, comma, y. But in this situation, the x and the y are actually the x, the 1, and the y1, because remember, that's the first point we have. If we had a second point, it would be x2 and y2. If we had a third point, it would be x3 and y3. So it's the point we have. Now, we may find ourselves with more than one point, which means we could write more than one equation, and we'll talk about that in just a few minutes. But this x1, so this is my point, is the x1 and the y1. The x and the y represent all the points that are on the line represented by this equation. So they don't have anything. So when you're done, those are always going to stay as x and y. So this is what we call, this is the sort of the generic form of the linear equation in point-slope form. What would it look like if we put in some actual numbers? So I'm going to keep that up there. So what would be the equation of a line with a slope of 2 passing through the point, let's go 3, 4. You know what? Actually, let's make it 2, -3. We need a negative because it's going to matter. Okay. Now, in the last lesson, we would have put this into the slope-intercept form, the y equals mx plus b, because they gave us an x, a y, and an m, and we would have used it to find the b value. Now we're going to have a new way we can write an equation. We're still going to be able to do that process, but it's going to be easier because we have this new form called point-slope. So now I'm just going to plug these values in. So it goes y minus, and my y value here is -3. So that's my y1. So this is my x1 and this is my y1. And that's going to equal 2, parentheses, x minus 2. So this 2 is this one, the slope. This 2 is this one, the x1. Now they're going to do one thing. We're always going to clean this up. Okay? They all follow my instructions and they put a little cheese on it because we would never allow ourselves to have minus and minus. So we would change that to plus. So when you're when you're looking at this, and I'll talk about this a little later on, and you're trying to figure out what's the point of the point-slope form, you usually are going to go back. When you want to go backwards, you usually use the opposite because it's always subtracted. So if you see plus, it's a negative. If you see negative, it's a plus. We'll again, we'll see that soon enough. But this is an equation in point-slope form. So we went from having just a point and a slope to, boom, I can immediately write an equation in point-slope form given I had a point and I had a slope. Okay, pretty straightforward, and very easy to work with. And you're almost always going to get pretty small numbers. But the thing you always have to be careful about is that you could have more than one equation to describe the same line, and sometimes that's where it gets really confusing. When you're like, well, which equation is the right one? And the answer is they're both right. Okay, so you might have one where you have more than one point. I'm not sure if we're going to see that in this lesson or the next one. Okay. Now, this might look familiar to you for some of you. You might be going, why do I know that? Why does that look familiar to me? Well, because it looks a lot like the slope formula. The slope formula looks like this. Whoops, not another y. X2 minus x1. Well, if we make this a y and this an x, well, it looks even more like that. And here's the really amazing thing is, it really is that formula kind of rewritten. I'm going to cross multiply this way. So the y minus y1 is going to stay y minus y1, and m is going to multiply times all of x minus x1. So this formula for finding slope and this equation for writing a linear equation in point-slope form are really very interconnected. This one is, hey, if I have 2 points, I'm going to find the slope. This is, hey, if I have one of those points and the slope, I'm going to be able to write the equation. Okay, so that's a big deal. The ability to now, I can write, and to realize that there's more than one equation that I could have. I could have multiple equations that describe the same line. Okay, because I could have them in different forms. I could have them in slope-intercept. I could have them in point-slope, and we will be seeing a third form in the next set of lessons called standard form. But we can always put them into these two forms, point-slope and slope-intercept form. Okay. Now, how do we graph it? Okay. Do I want it? Yeah. This is the trickiest part. Okay, is how to graph it from point-slope form. Okay, so y minus 2 equals 3 times x plus 4. I got a nice 2, 3, 4 thing going there, and I'm just going to use that. Okay, when you see the equation in this form, you have a couple of options on what you could do. You could turn this into slope-intercept form, and that will be our next lesson. We're not going to see that today. We're going to see that in the next lesson on point-slope form, which will be later on. But what we could do is, hey, I know this is called point-slope form because these two numbers represent a point, and this number represents the slope. So that's the easy. Let's start with the easy part. The slope is 3. I can always turn that into a fraction, and in fact, let me move that over just a little bit here, because then I have a rise and a run. So that number is my slope. That was pretty straightforward. It's called point-slope form for a reason. Slope is m. That's where the m goes in the equation. The hard part about this one is understanding the point. So the point is, again, always going to be an x and a y, but here's what you got to remember. The original problem was x minus x1. Well, what number would I have to subtract to get positive 4? Well, I'd have to subtract negative 4. And that's the x. That's the other thing that students struggle with, because it's second, but it's still x, which means when I write it in my ordered pair, I write it first. So even though this one was second, I'm going to write it first. And then this is the same thing. This is y minus y1. Well, I got the y, I got the minus. So what's the y1? Y1 has to be positive 2. So what you're grabbing for the ordered pair is the opposite of what you see there. So I see a positive 4, I get a negative 4 for x. I see a negative 2 for y. With the y, I put a positive 2 with the y. Because originally, the way that I got this plus 4 was that I had x minus negative 4. And since that's the way it's written in the formula, in the point slope form, then that is how it had to have been written to get that plus 4. And now I have the very simple task negative 4 comma 2 is right there. That's my point. And my slope is 3. So I'm going to go up 1, 2, 3, and I'm going to go over 1. There's my slope, my rise over my run. So I've taken my point out of the equation and my slope out of the equation to know how to graph it. We saw when we graph with slope-intercept form, we start at the y-intercept, so we're always starting right on the y-axis when you use slope-intercept form, and then we're using the slope rise over run same way. So the slope's getting used the same way. The difference is where do we start? With slope-intercept, we're always on the y-axis. With point slope, we could be anywhere, literally anywhere on the graph. There's nothing restricting me from being, that just happens to be the point that they gave me. They're obviously, because this line says that these arrows mean they can go in any direction, they could have given me this point down here instead as the starting point. It wouldn't make any difference on the graph. It'd still go up 3 and over 1. Okay, they could have given me this one, and I could keep going from there. There's nothing controlling where that point could be. So there's no restrictions. There's nothing that says, oh, well, for point slope form, it always has to be this or it always has to be that. There's no always. Okay. For slope intercept, you're always starting on the y-axis. For point slope, you could be anywhere. And I'd like to show one more example that almost always messes students up as well. Okay, so let me do a nice easy one. Okay, let's make it not super easy. Let's go plus 2 equals negative 3x. That's still point slope form. And I know what you're thinking. You're like, where's the parentheses? Where's the rest of it? Well, again, it sort of begs that question of, well, where is the rest of it? Why didn't I have a parentheses and a minus something out here? What would this have to be for me to have not put it? Oh, I know what it has to be. It has to be 0. Because why would x minus 0 is just x. So I wouldn't write it. It would be gone. I would just write x. So that means that for my ordered pair, my x is 0. That's the thing I got to note. Now, they love to do it in both directions. See, if they do it over here, it ends up looking more like slope-intercept form. But if they do it over there, it's a little more confusing. You just have to remember, if you don't see the parentheses, the only way that happens is if the number that would have been there was a 0. So it's not there, it's a 0. And over here, I have a positive 2. So for the y, I'm going to put negative 2. Whatever I see here, I'm going to put the opposite, because the only way that happened is if it was y minus negative 2. And again, my slope is really obvious. It's right there. It's just the number next to the x. It's either next to the parentheses with the x or the x itself. It's negative 3. And again, I can make that a fraction. And again, that's my rise and that's my run. The 1 is always going to be positive. If you're making something into a fraction, the denominator is always positive. You're always going to the right. Positive, the up or down is determined here. This is up to the right or down to the right. Okay, and now again, I am ready to graph this. I start at 0, negative 2, and I have a negative 3 slope. So down 1, 2, 3n/1. It actually kind of looks like slope-intercept form because I started on the y-intercept, on the y-axis, and graphed it following the slope. Okay? So that's part one of point slope form. Okay? Using this point either to put it into the equation or to get it out of the equation. Okay? Remembering, so I'm going to write it up here one more time. It's y minus the y value of the point that you're given equal to m, the slope, times x minus the x value that you're given. Okay? So that is point slope form of a linear equation. Okay? And I will see you in class or office hours.